So, as she pointed out, just as a reminder, next week, midterm exam. First hour of class on week 5. So that's next week. So expect questions similar to like what we've had for quiz questions. So you'll probably have to do a couple of number conversion type things. You'll probably have to write a short function in Python. It probably wouldn't be something too difficult in programming since we just kind of gotten started and you're just getting practice. So it would be something more along the lines of maybe write a for loop that displays a string backwards or something like that. You know, just can you do some simple stuff rather than solving very complex problems? You know, like today's quiz was write a function that takes two numbers and adds them together, right? That's a far cry from like converting a number from binary to octal or something. So really, if you go through the slides here, you know, there'll be something dealing with how do human beings solve problems. In fact, I might even ask you this exact question. You know, memory asking questions, repetition. I probably will not ask you questions specific to Mendix. Mendix was more of an introduction to programming. Did everybody see the homework assignment I had put up for that survey? So if you haven't done that, make sure you do it tonight before class ends or right after class ends or something like that. Because I meet with the research group tomorrow. We're going to talk about the results to that. So please help me out with that. You get some free points. Let's see. Talked about functions. Now we've been writing functions in Python. I might ask you what's the concept of a CPU. You know, this idea of a collection of magic tricks that pretty granular, that kind of stuff. Probably would not ask you questions like this that talk about like how the CPU is actually put together. It's not really part of this class, but I would ask questions from the CPU related to like computer programming. So maybe the idea of a high-level language versus a low-level language versus machine language and how those mappings kind of occur. You use a compiler to take you from a high-level language to a low-level, and then you use an assembler to go from a low-level to machine code that runs on the CPU. So that idea of a one-to-one relationship, that kind of stuff. Probably won't ask you about context switching. That's an operating systems topic. Nothing there. Certainly the bases, be able to convert from decimal to some base and also from some base back to decimal. Know the size stuff, so converting sizes. So if I told you, you know, you have something that is 7 gigabytes and I asked you how many kilobits that was, you should be able to do that conversion. Definitely the modulo stuff that you used for getting remainder and things like that. I probably would not ask you to do something that involves modulo for a programming question on this first test. I'm going to presume on the first test that your everybody's programming skills for doing something relatively quickly is going to be pretty weak. So the programming question or questions I put on there would be pretty simple. If I gave you a harder question, I would probably write the code and ask you, what does this do? So you should be better at reading code and saying this is what that guy does rather than writing it from the top of your head. Okay, that's always easier when you see the answer than when you're asked to write it yourself. Okay, so more than likely you'll still probably think I'll probably put one programming question on there. You'll probably still think it's harder than it should be or something like that, but I'm going to try to make it pretty easy. But I'm expecting you to either not do well on the question or for the question to be so easy that you'll accidentally do okay on it. All right, so this first test should not really penalize you based on your programming ability, as long as you can still read code. If I give you a function that I wrote, I asked you what would the output be of this program, you should be able to tell me that. Make sense? All right. So all these things about the different kinds of programming languages, so machine level, low level, high level. I probably won't ask you stuff about operating systems specifically. Compiled versus interpreted languages are fair game. Procedural versus object-oriented languages, I won't ask you about functional stuff. That's that telephone example we had. I probably wouldn't ask a question general purpose versus domain specific because we don't really have a context for domain specific at this point. So I probably won't ask you anything from this slide. I wouldn't ask you a question like list a bunch of programming languages. It's just a waste of time. I won't ask you stuff about HTTP specifically. That was more of just talking about the this idea of an API and protocols and stuff like that. So that's more of a networking topic. Important to give us context with what we were talking about, but not something I'm going to test you over. I'll ask you questions. I mean, you should be familiar with this. You won't have to like reproduce this slide or anything like that. But, you know, if I ask you, for example, you know, what was the problem with C++ that it empowered programmers to make bad decisions, that kind of stuff, you should kind of understand this evolution of languages as we step from the older languages to our newer languages. I'm not going to ask a lot of questions about that, but at the very least, you should understand those broader concepts. How our languages have improved, something like that. I probably will not ask questions related to some of the web languages, like this idea of MVC and Ruby with its own web server. I think that moves a little bit away from what I really want to test you on for programming knowledge. So even though the irony is that we're using one of the languages from the web side, we're using Python, we're actually using it as a general purpose language that would really belong on the other side. We're not using it for web programming purposes. So I probably will not ask you questions related to web programming stuff that we discuss with the PHP and the Python and the Ruby and that kind of stuff. Still important things to give you a background on this slide, but not really the stuff I'm focusing on. So you can probably ignore those things from a studying perspective. Definitely, you know, it's not so much memorizing this idea of, you know, C versus C++, but, you know the difference between a procedural language and an object-oriented language. We talked about arrays and structs. So structs are kind of like dictionaries. Arrays are like lists. I obviously wouldn't have you write any code or something in one of these languages. So, you know, you should think of C as being a procedural language, C++ being the object-oriented upgrade to that, you know, but had some problems with the whole pointer thing. They gave programmers too much control of memory. We talked about pointers. You should know what a pointer is, at least. You know, if I asked you a question of, you know, what's a pointer, you should say it's a variable capable of holding a memory address. You know, I don't know if I'd ask that question, but that would be fair game. I wouldn't ask you to, like, write any sort of syntax in C or anything like that. Like I showed you an example of that in class. You're not responsible for knowing that. That was more of just connecting some dots. Same stuff with Java. I probably won't ask a question about like the details of how Java sort of kind of messed up by removing structs. Again, that's more of a historical lesson, not really the type of thing I'm interested in having you learn from this, other than kind of knowing that they weren't perfect when they came up with their new languages. The idea of pass by value versus pass by address that we talked about probably will not be on this exam. It's something we are going to deal with, and we'll deal with in the second 4 weeks. So that'll make its appearance on the final, not on this first test. So even though we discussed it quite a bit with some different examples, because we don't have a direct experience with it with Python, I'm not going to test you over it yet. So you can ignore variable passing stuff for right now. Same thing, Android versus iOS stuff. This is more historical foundation stuff. I probably won't ask you this on a test. Microsoft, all that stuff. Not on a test, not on a test. I won't ask you anything specific about C#, but again, just understand the differences between those languages, how they've improved. As far as the, if I give you some Python code that I want you to read, things that I would probably put on there is string manipulation and list manipulation, which is what we're going to work on this last hour here, and what your homework will deal with. Strings is mostly strings, but also some stuff with lists. All right, that makes sense? So from a programming perspective, I would say be prepared to write maybe one pretty simple function somewhere in the ballpark of what I gave you for your quiz today. Maybe a little bit harder than that, but nowhere near what like you had for your homework assignment for today. But I'll probably have at least one, if not a couple, of functions that I write, and I ask you, what do these do? Okay? In fact, there's even a chance I won't even ask you to write any programming on this test. You'll definitely have programming on the final. But I might be more interested in, can you read it right now than can you write it? Will make some sense? All right, questions about the, and it's only going to be the first hour next class, and then we're moving on. We're staying for 4 hours. You'll take a test for the first hour, then you'll go get a bunch of diet soda to bribe me to give you a better grade in your test. Then we'll come back and we'll move on to new material for the next 3 hours. That makes sense? So nobody take off after you take the test. We got too much crap to get through. All right, go ahead. No notes. But the exam is not really going to be much memorization. Yeah, so I mean, it's going to really ask you to kind of tell me that you understand the stuff. If you want to use a translator or something like that, you can. That's fine. I don't mind if you do that. If you're unsure what I'm asking you on the test, come up and ask. I'll clarify for you, or I'll show you an example or something like that. I don't want the reason you do poorly on a question to be that you weren't sure what I was asking. You know, if you're going to suck on a question, I want it to be because you don't understand it. You know, not because you didn't understand the question. That makes sense? So if you're in doubt, come up and ask, and I'll try to clarify for you or nudge you in the right direction, that kind of thing. But if you would benefit from a translator or dictionary or something, that's fine. I know a lot of the other teachers don't let you have that, but I don't care. Just don't cheat. Anything else? It's up there, isn't it? Yeah, if you go to oh, I was already there. Yeah, if you go to 535, on the left-hand side, I have slides. Oh, did that not open anything? Oh. Well, let's fix that then. Let me make sure the link works, and then I'll find out why it... Okay, yeah, the link's legit. It's just not working in Blackboard. Okay, so let me... Well, here. Just as a backup plan, I'll paste it in Slack real quick. So there's the link to the slides. They're in Slack. That's live on the... So every time I hit save, you have it updated. Wonder why that is not showing up here. Set link to open in new window. Let's do that. So now when I hit slides, does that work? Ah, that was it. It was trying to embed it in its own window. The link should work now if you refresh the page. But it's also in Slack. Anything else? So if you think of anything before next week, just put the question in Slack or something like that. I'm happy to help. Okay, so let's go back and let's write some more Python then. Because the real issue we have right now is that before our break, Jade was begging me. He said, look, I know there's a built-in sort function, but I don't want to use it. I want to sort my random numbers by hand.
I never said that. Don't believe him.
I could pretty quickly give extra credit to everybody in the class, and they will just turn on you so quick. It's so bad. It's anything for a grade. All right. Here, let me. I'll paste a couple of these functions up on Slack just because I want to clear this out so I can do our sorting stuff here in a second. So I'll just give you some more code example crap up here. I'll just say string manipulation examples. Okay, so we got that. So now I can delete stuff. All right, so just as a reminder, I had to bring in an external library in order to do the random number stuff, so I just had to throw import random at the top, and that let me do the magic. There's a bunch of different ways to generate random numbers. That's just the first one I found when I looked up. So we went ahead, we created an empty list that is a list with 0 elements in it, and then I went through and I did something, I repeated something 100 times. Each time I appended something to my list, making it 1 longer than it used to be. And what did I append? I appended some random number between 0 and 100. All right, then I go ahead and I print out those random numbers. So we'll just see that again here real quick. So there's my random numbers. Now, again, Jade said, we have that sort function built in that sorts the things all nice and pretty. So now they're in ascending order, like that. But he said, I don't want to use that. That's too easy. Right? I mean, if you're going to sort data, you don't want it to just be a 1-line easy thing like that. You want to feel like you had to write the algorithm to sort. Right? Well, yeah, but after we do it the hard way. Right? All right, so let's look at a sorting algorithm. So I'm going to draw us a picture here. All right, so we're going to say we have a 4. Then we have a 1. Then we have a 2. And then we have let's do a 6. And we'll do 1 more. So that's a 3. All right, so we're going to assume that we have a list of 5 elements that's already filled up with random numbers. Okay? Now, I'm just going to go ahead and I'm going to label these buckets just for our own memory. So this is bucket 0, bucket 1, bucket 2, bucket 3, bucket 4. So that's the index of those buckets. Okay? So now we want to look at an algorithm for sorting these elements. Okay? So what we're going to look at here is something called an insertion sort. So it's one of the kind of the known sorting algorithms. So the way insertion sort works, I'm going to walk us through it here. We're going to have a variable here called the follower. We're going to have another variable called curStart. All right. And we'll have a couple pictures. So we're going to have curStart start off at bucket 1. So not the very beginning of the list, but the first element, the second overall element in the list. And then we're going to make follower point at that same place. Okay, because curStart is going to tell us each time through where are we starting from. So curStart's going to start here, the next time through it's going to go here, then it's going to go here, then it's going to go here. And we know we're done once curStart's off the end of the list. Follower is the guy that's going to help us put this in order. All right, so I'm going to ask the question, should a 1, well, first of all, I'm going to say, is the position of follower at the beginning of the list, or do I have something before me? I have something before me. Should the value that I have here come before the guy before me? If the answer is yes. A 1 should come before the 4. So we're going to swap. All right, so I'm going to need a little like extra storage place up here. So maybe I'll put the 1 up here. Then I'll copy over here the 4. Then I'll copy over the 4 my 1 that I had stored temporarily. And then the follower follows. Then we ask the question again, is the follower at the beginning of the list? It is. So I can't compare myself to anybody after me. So I'm done with this round. So now I increment curStart. I reset follower. Well, I asked the question, is curStart off the end of the list? Nope, I'm still cooking. Reset follower to here. Is curStart at the beginning of the list? It's not. Should a 2 come before a 4? It should. So we'll temporarily store the 2 here. We'll overwrite the 2 with a 4. We'll overwrite the 4 with what we had in temporary. The follower follows. Is the follower at the beginning of the list? Nope. Should a 2 come before a 1? No. So we're done. Increment curStart. Is curStart off the end of the list? Nope. Reset follower. Is follower at the beginning of the list? Nope. Should a 6 come before a 4? Nope. So we're done with that round. Increment curStart. Is curStart off the end of the list? Nope. It's at the end, but it's not off the end. Okay, so it's still a legal position. So we'll reset follower. Is follower at the beginning of the list? Nope. Should a 3 come before a 6? Yep. We'll preserve the 3. Overwrite the 3 with a 6. Overwrite the 6 with the value we preserved. The follower follows. Are we at the beginning of the list? Nope. Should a 3 come before a 4? Yep. We'll preserve the 3. Overwrite the 3 with a 4. Overwrite the 4 with the value we preserved. The follower follows. Are we at the beginning of the list? Nope. Should a 3 come before a 2? Nope. So we're done with that round. Increment curStart. Is curStart off the end of the list? Yep. And our list is now ordered. Make sense? So that's called an insertion sort. So we're going to go ahead and write that guy. You glad I didn't give that to you for homework? Man, the assignment you have is so much harder than this one. It's like, it makes this one look like little children should be writing it. So, so we're going to go ahead and say insertion sort, and this guy will take in a list as a parameter. So we're going to define a couple of variables here. So I'm going to have my variable called follower. Now, I'm going to actually have a loop that's going to start from bucket 1 and go all the way up to including the last legal bucket of my array. So I'm going to say for I in range, and actually let's call this guy to match our thing. We're going to say cur start. For cur start in range from 1 to length of list. And we are going up to length of list because it won't include that. So this would be up to length of list minus 1. All right. And we don't have to put it here, but we're going to take the normal step of 1. So we're going to go from bucket 1 to bucket 2 to bucket 3 to bucket 4. So this piece here is optional. The default is step by 1. So you can either say it there or you can just omit it. It doesn't matter. Okay. So I'm going to take cur start on a voyage between bucket 1 and the end of the array. Each time we start here, we're going to say follower gets reset to the current value of cur start. Okay. Then we ask the question, is the follower at the beginning of the list? Well, we ask if it's not at the beginning of the list and it's supposed to swap with somebody else, then we do a swap. So we're going to say while follower is greater than 0, so as long as he's not currently pointing at the beginning of the list, and list at position follower is less than list at position follower minus 1. While both of those things are true, I'm not at the beginning of the list, and the guy I'm currently looking at should come before the guy before me. If that's true, then we're going to say temp is equal to list at position follower. So we'll preserve that guy. Then we'll say list at position follower is equal to list at position follower minus 1. Then we'll say list at position follower minus 1 is equal to temp. Preserve whatever's at position follower, overwrite follower with follower minus 1, overwrite follower minus 1 with the value we preserved. That does the swap. And then what does follower do? It follows. It moves towards the front of the list. Now this spins back up. Is follower still greater than 0? If it is, should we also do a swap? If we should, do the swap, follower follows. If not, if we either have run out of places to follow or we shouldn't do a swap, we fall out of this while loop. And our program is done. So now I'm going to call insertion sort on my random numbers. And then I'm going to print this guy out, and we're going to see something here. So here's going to be my unsorted numbers. Then I'm going to pass my list of unsorted numbers into insertion sort. This guy is going to do his whole thing. And then I'm going to print my numbers out again afterwards. Is that sorted? Yeah, it's sorted. So here's the question. Did I ever return a value in here? So I passed my random numbers into insertion sort, and now it's just magically sorted? How? Well, lists are mutable. That's true. But this is the function. This function died right here, right? I didn't even I called my function one time right here. And I didn't say anything like my random numbers is equal to whatever insertion sort returns for this guy. I passed this guy in here. This guy made some changes to it, and those changes had a global effect. They had a side effect. So out here, I noticed that my changes actually occurred. What does that tell me about lists? When I passed this list to this function, remember we talked about in the notes, and I said I wasn't going to ask you about this on the midterm, and I won't. It'll be on the final. But when we pass this list to this function, a list can either be passed by value or by address. This guy was passed by address. How do we know? Well, the evidence is that I passed it, I changed it, I never returned it. Yet, my changes were realized out here. Those changes were permanent because I passed insertion sort where in memory my list lives. So he went up there and started screwing around with that list. And then when this function ended and I came back out here to my main program, I now have a modified list, even though my insertion sort didn't return it. That make sense? Okay. So that is insertion sort. Isn't this easier to write this than just to call dot sort? This was a good idea you had. All right, so let me give you this one as a starting point. And then I'm going to give you a little help with the homework assignment. Unless you don't want help. You don't want help? This is our homework assignment for next class. Is we're going to write a function called process expression. And function process expression is going to take a string as a parameter in, and it's going to take something in that looks like this. 123 plus 2 times 4, something like that. Be as long as you want it to be. All right? And it's going to take in that string, and it's going to give you the mathematical answer of this, assuming you do everything left to right. So you do not have to take order of operation into consideration. If we were doing proper math here, we would do 2 times 4 first to get us an 8, and then this would be 131, correct? In your assignment, you'll go left to right. So this would be 123 plus 2, so that's going to give me 125, times 4, which will be, 123 plus 2 is 125, yeah, 600. So this should output 600. That makes sense? So that guy should output 600. 123 should output 123. If I do something like 15 divided by 2 minus 1, something like that, it should do integer division. So 15 divided by 2 is going to be 7. 7 minus 1 will be 6. Right? Makes sense what we're trying to do?
Okay, but who can insert this number? The user or?
Doesn't matter. I mean, you can have the user write it, or you can just pass it in, just like we've done here. You know, I went ahead and filled an array of random numbers, and then I passed it to my insertion sort. So you can, you know, if you're going to have a function up here, def process expression, and this guy is going to take an expression as a parameter. I'll just print out the expression again in there for right now. So then down here, I can say my expression is equal to 123 plus 4 times 2 or something like that. And then I would call process expression, well, I would say maybe answer is equal to passing it my expression. So you would write the example expression like this, or if you wanted to get user input, you can read it in from the user. It's up to you. The important part is this logic. Okay? So now, what are some of the pieces that we're going to need in order to do this? Let's think about how we would solve this problem. I'm going to go ahead and dump this stuff to get this slimmed down here. Okay, so this is coming in as a string. I need to get the numbers out of this, right? There's two different types of things that exist in my function. Oh, and another thing I'll point out here, you do not need to support negative numbers. All right, so all numbers are positive numbers. The only thing that exists in our string are numeric digits as well as operators, plus, minus, times, divide. So 0 through 9 and plus, minus, times, divide. Those are the only legal things in our string. To make life easier, you can also assume that your string has no spaces in it, just like this. That'll make life easier for you. All right. You can write it without, if you assume there are spaces, it's not that hard to write, but if you want to keep things as easy as possible, assume there's no spaces. So what we're going to have to do here is, as we're walking through our string here, we're going to have to walk through one bucket at a time. And we're going to have to ask myself, is this an operator? No, it's a digit, right? So I should keep it. I want to start collecting 1, 2, 3 until I finally hit an operator. Does that make sense? So I'm going to walk through my string. I'm going to say, I have the empty string. Is this an operator? No. Concatenate that guy onto my empty string. Is this an operator? No. Concatenate that guy onto my running string. Is this guy an operator? No. Concatenate him onto my running string. Is this guy an operator? Yes. So that means that my current string holds a number. Does that make sense? Then I'm going to read in my operator. So if we kind of think about this at the high level, I'll draw the algorithm for this. So this is my expression, for example. Okay? And then I'm going to have maybe a first num variable. And I'm going to have a cur pause. Cur pause variable. Now, cur pause is going to keep track of where we are in our string. All right. So I'm going to have a first num. I'm going to have a second num. And then I'm going to have an op. Go ahead.
123. We counted as a 1, number 2, number 3, number 4, one number as 123.
This is the number 123, but you're going to need to get that number as a 123. So what I'm going to do here, so I'm going to walk you through this algorithm. So I'm not going to write it for you, but I'm going to walk you through it. And then you'll have to convert this algorithm into a solution. That make sense? So you'll probably want to rewatch this portion of the video a couple times. So we're starting at the beginning of my expression. First num is going to start off as the empty string. Second num will start off as the empty string as well. So what I'm trying to do here first is I'm trying to build up my first num. Now you'll find this handy. I'm going to set cur pause, or cur op rather, equal to a question mark. The reason I'm setting it to a question mark is that's saying I do not currently have an operator. That's me letting myself know that I have not hit an operator yet. Okay? So before I hit an operator, I need to collect my first number. So I'll hit the 1. Is that guy an operator? It's not a plus, minus, times, or divide. So what do I do with it? I tack it onto first num. Then I increment this guy. Is that guy an operator? Nope. I tack it onto first num. I increment. Is this guy an operator? Nope. I tack it onto first num. So I've built up that number in first num, right? Is this guy an operator? It is. Since he's an operator, I need to look at do I currently have an operator? I don't. So I'm going to go ahead and capture this guy. That's the operator I'm going to need to do. That's the math I will be doing. Operators always have a value on the left-hand side and a value on the right-hand side. Okay? So since I didn't currently have an operator, I'm not doing math yet. Instead, I'm collecting my second number. Okay? So now I hit the 2. Is this an operator? It's not. So I build it up in here. Then I hit my next value. Is this an operator? It is. Then I notice, wait a minute. The current value I have, my current operator, I already have an operator in there. So since I just had another operator, that means I have to do some math first. So what math am I going to do? I'm going to perform addition between these two values. So you're going to need to convert this guy into a number. And you can use the solution from your homework assignment to do that. Or you can maybe use the trick that he pointed out. But you should already have functions now that can convert a string representation of a decimal number into the decimal version of that, right? Base 2 decimal that we wrote. If I pass it the string 123, along with saying it's in base 10, it will give me the number 123, will it not? Yeah. So you can turn that into the number 123 using a function we wrote for homework today, that I wrote in class today. Okay? Or you pointed out there's some built-in things to do it as well, but you have everything you need. So we're going to turn that guy into the number 123. We'll turn this guy into the number 2. We'll add them together, giving us the result, which will be 125. And then we're going to store the result back in here as a string. Okay, then we're going to go ahead and empty out our second number. Put a question mark back there. Well, you actually probably would have just put the asterisk in there, but we basically have finished using that operator. We have finished using our second number. We've performed the math, putting the result back into first number. So now I'm going to store that multiplication here in curop. So since now I have an operator, I'm going to start building up second number. Is this an operator? Nope. Collect it. Now, I've walked off the end of my string. When I've walked off the end of my string, I might have one last thing of math to do. Now, keep in mind, you won't necessarily have a last thing of math to do. If my expression had just been 123 with no operators in it, I would have walked off the end of it, and my answer would have already been inside of first num. But since since I'm done moving through my string, and since curop currently has an asterisk in it, I know I need to do some math. So I'm going to convert the 125 into its numeric equivalent. I'm going to convert the 4 into its numeric equivalent. I'm going to multiply those guys together, storing the result back into first num. Then I can zero out this guy, turn back the empty string. I can set this guy back to the question mark, and then my final answer was stored inside of first num. So I can return the answer, which is in first num. That make sense? If we, let me just steal this slide and I'll move it to a second slide. Let's assume that my answer just looked like this. My expression just looked like that. This is the empty string, this is the empty string, this is the question mark. Is this an operator? Nope, collect it. Is this an operator? Nope, collect it. Is this an operator? Nope, collect it. Now I'm off the end of the string. Then I ask myself, do I have to do one last thing of math? I check cur-op, it's a question mark, I don't. I'm done, my answer is in first num. That make sense? All right, so does the algorithm here make sense on how to write this? Okay, so if I have an expression like this, what's the length? Well, here, I'll ask it in this. What's the length of this expression? Well, you're counting it from there, but the length of that expression is the length of that expression. It might be 7, it might be 3, it might be 50. We don't know. So we need to generically write it here. Okay? Now, if we look at our algorithm here, no matter what we did we walk through every element of this string from the beginning to the end? So no matter what we do here, you're going to have your standard for loop for I in range 0 to length exp. You're going to have that for loop. That takes you on a voyage between 0 and the last legal bucket of that. Okay? You know that you're going to have a, what did I call the variables? First num, second num. First num will start off as the empty string. Second num will start off as the empty string. Cur-op will start off as the question mark. Make sense? So now as you're going through here, if your first num is currently empty, you know you are collecting a, well, really, if cur-op is currently the question mark, you know you're collecting first num. If cur-op is something else, you know you're collecting second num. That make sense? So you'll be concatenating onto first num the value, or you'll be concatenating onto second num the value, and then sometimes you'll also then do math. You'll have to decide how you're going to accomplish that math. All right, questions about this homework assignment? I'm going to put it up on Blackboard. All right, so any other hints you want me to give you besides writing it? So we're not that far from it just being done. Couple things I'll say is when you're doing this assignment, follow the algorithm that I pointed out here. Don't spend a bunch of time going and look to see if there's some built-in thing in Python for processing an expression. Okay? There might be. I don't think there's going to be a convenient one for you doing it this way, but you know, you want to get practice solving the problems this way. So I've given you the step-by-step instructions for solving this problem. So now you just have to convert those instructions into Python code. Right? And we have all the tools that we need. We already have the ability to convert a string-based number into a real number. So I can come in here. Here, I'll just, for the time being, I'll just do a print I so this will run. So I can come in here and I can say print the int version of 123 plus 5, and that will give me a 128. So I can convert a string into its equivalent integer in Python pretty easily. Even if we didn't know about that, because we wrote a function today called base to decimal, we could have done this anyways. But it's built into Python, so I should see I'll get a 128 out of that guy. So there's my 128. Okay, so we're going to need that tool. We're going to need some if statements. We're going to have to ask if op is equal to the plus sign, do addition. If op is equal to the minus sign, do subtraction. So on and so forth. So we're going to have to ask some questions. All right. Any other questions? Comments? Concerns? Bribes? Yeah, bribes. You thinking about it? You don't want to learn? Okay. If you've not already done so, go and do that survey right now so you get it done. If you have done it, make sure you submit the screenshot so I can give you full credit. Yeah, go ahead.
So, we have we are getting this assignment. So I want to know when the assignment will be due.
It's due before class starts next week. You got a week to do this.
Sorry, doctor, you need a week to do this?
Well, I'm giving you a week to do this. With the right size bribe, we could have this done in 5 minutes.
I have 3 projects captured.
How's that my problem?
And it's not yours.
Yeah, it's not mine.
It's mine.
And I've given you I've given you the solution.
Yeah.
I've done everything except write the last 5 lines of code.
But remember yourself when you were 14.
Oh, when I was 14, I was brilliant. Oh my gosh, I was so smart at 14, so young and fresh. Now I'm old, forgetful. I've given you most of this assignment. It'll still be challenging, but if you follow the video, the steps, and then convert that into the Python, I think you'll find that, you really have most of the answer already here. Okay? Yeah, you will struggle. This will be tough. But it's not going to be tough because you have to write 100 lines of code.
No,
You're going to have to write 7 lines of code, and it's going to be, you're not going to like those 7.
I think the problem is not with the struggling with the time. This is the problem.
The time?
Yeah.
We got a week.
We got to start it for a midterm.
Okay, hold on a second. Because he brought it up 2 classes ago, you complained a couple classes ago that I've changed this course, right? Yeah, you've pointed out that I've changed this course. So since you knew how I taught this course before, maybe you want to share with the class what the assignments typically look like in this class. Every week you would typically have a program bigger than this and a 3 to 5 page paper you had to write every single week. Is that in line with what you saw from this class before?
Yeah, I heard about it. I'm not complaining about here. Nobody can complain in this department.
So it could be worse, promise. Shall I give you the paper too? Maybe you want a paper.
No, please. It's enough. Believe.
You see how quickly we've shifted from, oh, I only have a week to do this, that's too much work, to all of a sudden this is enough, please no more. All right, I'll see everybody next Wednesday.